Hey guys, welcome back to another source code review. Today, we're going to be looking at an incredibly popular library. If you work in the JavaScript ecosystem, you have undoubtedly heard of it, if not used it, and that is Axios. So let's hop on over to Axios' GitHub page. And we see here, it is described as a promise-based HTTP client for the browser in Node.js. Now, like all of my videos, if we're going to do a source code review, I highly recommend that you be somewhat familiar with the library. I'm not going to teach you how to use Axios today. Perhaps we'll do that in another video, but for now, we're going to be deep diving into the code and looking at how Axios is implemented. Now, hence the About section we just read, you know that Axios is a client for both the browser and Node.js. This means that it is isomorphic, it will run in a Node runtime, it'll also run in a browser runtime, and if you've been working with JavaScript for a while, specifically if you've been writing both server-side and client-side JavaScript, you'd know that making network requests in Node versus the browser is a different process, at least until Node 18 dropped a few weeks ago and they implemented fetch in Node. But for pretty much all of history up until a few weeks ago, this was not the case. If you were in Node, you would have to either add a polyfill for fetch if you even wanted to use it. And Axios was really implemented before fetch made its debut. And so we're going to see this in the source code that Axios relies on two different adapters for implementing network requests. But let's not get ahead of ourselves. Let's grab that Git remote and clone this repo. Gonna go ahead and open up a shell, cd into my temp directory per usual, and clone Axios. The very first thing we're going to do is hop on into this index file, and we can see there's a simple single line. We are exporting this module that lives in lib/Axios. So let's go hop on over there. And we can see here that we are using an older CommonJS syntax as well as a lot of ES5 syntax. And a lot of people ask me, why do people still use var in documentation and tutorials even though ES6 is old news? Well, I suspect that Axios actually uses this syntax so they don't have to go through an extra transpilation step, and they can offer better supportability and interoperability with the library without having to do a bunch of stuff and transpile this code down to ES5. Or it could just be the fact that this library has been around for a very, very long time. So we hop on down here, we can see that we're creating a bunch of global variables that we are then exposing as part of the Axios public API. And these should look pretty familiar. We have the Axios variable itself, which we are getting from this create instance factory function, which we will look at in just a moment. We're also assigning the Axios class onto a property on this Axios instance in case somebody wants to grab the class and extend from it. We also have a few helpers here. We have a cancel token. We also have a few helpers related to cancel tokens. We have some metadata about the package, and we have this other utility function to form data. We have the Axios error class as well as the canceled error for backward compatibility, and then we have the Axios.all and .spread utilities, which, funny enough, Axios.all is literally just a wrapper for promise.all. And then, of course, down here, we set module.exports and exports.default to point to Axios. Let's get into the meat and potatoes and check out create instance. This is very apparently a factory function for creating instances of this Axios class. We pass in this default config, which is the configuration for the Axios client. Now, as you know, with Axios, you can either create HTTP requests on the fly, or you can actually create an instance of the Axios client and reuse it across your code. This provides for many powerful patterns, such as implementing interceptors and transformers, which are a chain of functions that will fire before and after your request is made and give you an opportunity to intercept that response and either format it or normalize it or handle errors in a specific way. And it can really just generalize your code base and help keep a lot of that network request parsing logic out of the business logic for your components on the UI. And I'd suspect many of you who have been around the block and are accustomed to using XHR to make network requests really appreciated Axios when it dropped into the community, because it truly abstracted away an insane amount of logic that you used to have to implement before we had the advent of the fetch API. But back to create instance. The first thing we do in create instance is we create this context using the Axios constructor. Here we have this instance that we've created using the Axios constructor, and we've bound the prototype as well as this context to it. And you'll notice that we're binding this to the actual request method on the prototype. And this is what allows you to use Axios as a client constructor as well as to just straight up make network requests. And let's bounce on over to the documentation real quick and we can take a look at this. And you can see right here, you can use this Axios object to just fire off requests, or you can use the create static method to create an Axios instance. In fact, you can see that static instance being declared right here. We have instance.create and we're setting it to this function expression, which is quite literally just a wrapper for create instance itself, where we merge the config into the config passed into the create function. And once the instance is created, we go ahead and return it to the consumer. I think the next logical step for us is going to be jumping right into the Axios constructor. And as you can see by the usage of the this keyword, this Axios function is actually a constructor function much in the same vein as ES6 classes. Axios, however, was written before ES6 classes were introduced to the spec, and this is a pattern that you'll see among lots of ES5-oriented code bases whereby the actual prototype is built manually. This provides developers with a lot of fine-tuned control over the factory function and how the instance is constructed. The very first thing we do in the Axios constructor is we set these defaults to the instance config. Now remember, the instance config can be something like this. We can have a base URL, and this means that all methods called off of this instance are going to use this base URL as the base path. We also have a timeout or headers. These are also going to be inherited whenever a network request is made using one of the methods bound to this instance. We also set this object called interceptors with a constructor called Interceptor Manager. We're going to take a look at this after we finish looking at the Axios constructor and its methods. The first method we have on the Axios prototype is request. And request, hence the name, is how you make a network request. You pass in this config, or you could just pass in a string URL as well as these config options. We can see here that we do some validation logic to check whether config or URL is indeed a config or a string URL. And then we go ahead and set it. We see now that we're checking the method, we're converting it to lowercase. This is how Axios knows to make a GET request if you just completely omit the method. And now we see in the request function that we start to kick off the interceptor chain. Now, interceptors are probably one of the most powerful features that are shipped with the Axios API. It's one of the things that I love about Axios. They give you these interceptors, and it's essentially these chains of callbacks that the request or the response object is going to be passed through. Think of it very much like a pipe or compose function if you're familiar with functional programming. This is where we actually run the request interceptors before we proceed to make the actual request. And now if we go down here to line 117, we actually have dispatch request inside of a try catch. We'll look at dispatch requests in just a moment. After this try catch, we go ahead and we do the same thing we did up here in the request interceptors to the response interceptors using the promise returned from dispatch request. So let's go ahead and dive into dispatch request because this really looks like the core of the request function. So in dispatch request, we're doing more with the config options. We're also throwing an exception if a cancellation is requested. And this logic is going to work with either the cancel token, which is now deprecated in Axios, or the signal from the now built-in abort controller. So if we go back to dispatch request, we can see that we're actually calling one of the transformer functions. The transformers are very similar to interceptors, but they allow you to format the request data. And we can see that here, we're passing in transform request. We're also normalizing headers here. And here we're iterating over all of the HTTP methods and running a function called clean header config, which should give us a fairly decent idea of what this function is doing. We're deleting all of these off of the headers to clean the header config. What I would presume here is the Axios core is deleting any of these if they exist in the headers, because if they were there, that could cause our request to be malformed, hence the name clean header config. So they're trying to just get a blank slate, a tabula rasa, and get all of this stuff out of the headers if they are there. And then we go ahead and we set the adapter, and the adapter could either be configured by the consumer, or we go ahead and fall back to this default adapter, and we'll look at the adapters in just a moment. And now we're invoking the actual adapter, and that gives us a hint as to what the adapter might be. The adapter is eventable, and in that chain, we are running onAdapter resolution where we get the response, so we can kind of assume that adapter is some sort of HTTP network request interface such as XHR or the HTTP module if we're in Node. We get this response, and then we are passing it into the response transformer. We're also passing in a second callback function onAdapter rejection. So this tells us that we're using a classic Node callback style for this promise. We're chaining the .then. We're passing in the first callback for whether the promise resolves, and then we're passing in this error callback to handle cases in which the promise rejects. Let's go ahead and look at what the default adapter might be. So we get adapter in this defaults object from this function getDefaultAdapter. And now we see here if XML HTTP request is defined, we know we're in a browser environment, so we go ahead and require this XHR adapter. Otherwise, we do some validation on the process object to determine whether we're in a Node environment and it's safe to rely on the HTTP module. And we'll see here that we're leveraging CommonJS's module system by using these inline require statements. The reason you'll see this in a lot of CJS-oriented code bases, instead of having this at the top of the file where these required modules would need to be loaded in cache the first time this module is loaded, we put them inline in the function so that way we can defer their execution until we've actually invoked getDefaultAdapters, and we know that we really want to incur the computation required to load these in. So let's take a look at the XHR adapter. Now this is precisely why a library like Axios exists and is so insanely popular. This is how you used to have to make HTTP requests back in the day in the browser when Fetch API had not been implemented yet. We see down here, we're creating our new XML HTTP request and storing it in this variable request. Now we're checking HTTP basic authentication. Axios also helps alleviate lots of pains pertaining to cores, headers, and basic auth in HTTP. In fact, we see here if the auth option is set at all, Axios assumes that there is a username and a password set there, and it goes ahead and sets these on the authorization header using basic auth, where we append the username to a colon and then the password, and then we convert it to basic C4. You'll see basic auth used in an authorization header like this if you are using JWT authentication. However, if you are using cookies auth, you would set the with credentials property to true. Then we would go ahead and take the URL and any URL passed in on the config, and we would build a full path out of these. And then we see here we build the full path using the base URL and any URL passed in on the config. What's interesting here is we call request.open with that method. We convert it to uppercase to be compliant with the actual HTTP specification. And then we build the URL using the full path, any params or query strings, and then we pass in a params serializer. Now this could be something like the npm package QS if you wanted to pass that in and have a more robust serializer. And that's why it's on this config option. Axios actually allows you to set your own. So if you want to use a third-party library to serialize your URL parameters, you can do so. We also set the timeout if it is there. And now we start declaring functions to handle those events that are emitted by the XHR adapter. Again, I just want to reiterate, look at how much code is involved here. This is all of the things that Axios does under the hood so that you don't have to. And as aforementioned, we see with credentials, this is going to be used if you're using cookies authentication. We see a little bit of browser-based branching logic here. Again, Axios is isomorphic. It is designed to run both server-side and client-side, but you're probably not surprised to find that there is certain logic that we simply do not try to invoke if we are in a Node runtime. Among those is handling cookies. And here we use that for each utility to set different request headers. Now I want to clarify that headers in Axios are request headers, not response headers, and this has some rather intriguing implications when it comes to CORS, or cross-origin resource sharing. There are certain CORS-related problems that simply cannot be resolved by adding values to these headers. This causes a lot of confusion. I've seen this on lots of projects that I've been on where devs will be very, very confused as to why they cannot remedy CORS issues by passing different headers to Axios. Typically, to do this, you're going to need to implement an HTTP proxy on your dev server, such as those provided to you out of the box by bundlers such as Webpack and Vite. But with Axios, nope, it is not going to do that for you. And then we see after all of this logic, we finally get to send the request. And now let's go ahead and take a look at the HTTP adapter. Now this is going to be used in Node environments. And because we're in a server-side environment, we can actually proxy the network requests. So our HTTP adapter is simply going to return a promise. And this promise accepts something that looks very familiar and arity to us as something we saw before. We get the resolve callback and the reject callback, and we know exactly where this is going to get passed in. So if you go back to Axios here, we try to find where that adapter function call was. And it's not going to be in this file, it's a dispatch request. We see that adapter is itself a function that returns a promise, which is going to be the resolved value of calling adapter with config, and then we call .then, which is the same as calling .then on this promise, passing in resolve and reject promise. So let's just refresh real quick. We see that this is what we do in the resolve case, and this is what we do in the reject case. We simply run these transformers, and then we return the response, or in the case of the error, we use promise.reject. Let's go back to HTTP. So we have our inner resolve function and our inner reject functions that call this done function that do a little bit of cleanup logic if there was a cancel token or an abort controller signal passed. If we had a cancel token, we unsubscribe, and if we had an abort controller instance, we use remove event listener. These wrappers are also going to call our callbacks that are passed into the promise here. And now this should look very familiar to you after looking at the XHR adapter. We see we have some special handling for blobs, as well as text and streams. Let's look at the settle function real quick. Simple enough, this checks the response status, the HTTP response status, and determines whether to resolve or reject with this special class Axios error. We're doing some protocol checking, iterating over headers and setting them, some user agent logic, which it looks like this was a bug fix, handling form data, array buffers, and we have our basic auth that we saw in XHR as well. Naturally, the adapters have to implement something of a aligned contract. Interesting enough, we try to build this URL, and then we handle the catch case, and then we proceed to build it again in this options object. Interesting. We have more logic at the network level, including dealing with the transport type. And yes, folks, this is how complicated network requests can get in Node when you have unbridled access to system calls and kernel logic. Now we're formatting the response object, and this should look very familiar if you've used Axios. This is going to be the response object that is normalized and then returned. So we are handling just about every possible case here. I highly suspect that if we were to go dive into the git commit history of this repository, we would find that this file, this adapter, has just progressively expanded over the years. One of the fascinating things about open source, when you implement logic such as a network request using the collective knowledge of software developers on GitHub. Before we wrap up, let's go ahead and look at this Interceptor Manager class. So Interceptor Manager is another constructor function much in the same vein as the Axios constructor function. We declare an array on this context called handlers, and then we have our .use function. As you guys know, when you are using Axios, you can use this .use function. Let's go ahead and take a look at that. We grab our instance, and on that instance, we say interceptors.request.use. We can pass in this callback function. And as we saw, this is going to fire any time that request is about to go out. They're going to pass us the config, and we can do things with it and return it. We also have a callback for handling an error with the request. Similarly, with response, we can pass in these two callbacks to handle the case where the response is successful or the response is erroneous. In interceptors, this is such a useful pattern with HTTP requests because when you are implementing API calls throughout a front-end code base, things can get really messy when you don't have the luxury of compartmentalizing your HTTP response parsing logic from your actual UI code. And it can be really nice to simply build an HTTP client in some sort of services directory and handle all of the response normalization there, and you can effectively implement that using interceptors. You could get the response, and then you could format the response into a predictable shape. And then anytime you're making HTTP requests in your components, you would know that the response is going to have, for example, an OK property that's always going to be set to true if it was a 200 range status and always set to false otherwise. And if you wanted, you could even handle the error case and return a normalized object as well, so you don't even need to worry about the API call throwing inside of your component. So we're back at the use function, and we see here we pass in the fulfilled and the rejected callbacks that we saw just now in the docs. This is our success case and our error case, and then we go ahead and we push this object into the handlers array. And then here we return the handler's length -1. Interesting. So it says here it's an ID used to remove interceptor later. We also have the eject method, which allows us to take that ID that's returned by use, and we can remove the handler from that internal array. And we don't actually remove it, but instead set it to null. We have another function on the prototype called clear that sets the handlers back to an empty array. We also have the for each helper, which internally uses this for each function in the Axios core's utilities to take the handlers and for each handler run this callback function where if the handler isn't null, which we know it could be because we may have ejected it, we go ahead and invoke it. That was our deep dive into the Axios source code. I would not be surprised if you're very, very familiar with this library, but maybe never had a chance to take a look at the source code and see what is going on under the hood. I hope you enjoyed. If you did, please like, comment, and subscribe. We're going to be doing plenty more source code reviews in the future, and we'll see you guys next time.